Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of Transpower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. I also work as a theoretical economist and as an operations researcher. So I belong to the Institute for Operations Research and Management Science. So the first commercial software package my company came out with was in 1982. It's called Optimal Manager. It's applied operations research, applied management science. The package contains 47 program units to optimize your business. All the equations are contained within each program unit. You just enter the input. The user interface was remarkably advanced for 1982. The last revision I made in the program was 1990. It runs on any version of DOS or Windows, but for Windows 64 bits, like what I have here on my system here, I use the DOSBox emulator, which unfortunately doesn't have a config.sys file, so I can't use ANSI-IBM.sys in there, which means that some of the input is offset, but that's all right. You can just look at the array index and enter the data. The output is not affected in the least, so the output is perfectly aligned. That's all that really matters. All right, so you see here the sign-on screen. I'll just hit enter. Well, I gotta select the box first. Okay, now I hit enter. There are four modules: optimal product investment, product manufacture, product distribution, and product pricing advertising. We've been working so far on optimal product investment, and we still have some program units to go, so I hit I. We've already covered product demand forecast, decision making without sampling, and decision making with sampling. So today we're going to look at program unit 4, profit prediction and break-even analysis. This one is a little bit deeper than the two previous ones. So let's hit 4. Let's look at the program unit description. So I'll just read this to you. This program unit performs profit prediction analysis and break-even analysis. For the case of deterministic variables, the program unit calculates profit versus volume with fixed profit contribution and fixed cost, profit versus profit contribution with fixed volume and fixed cost, profit versus fixed cost with fixed volume and profit contribution, break-even volume versus fixed cost with fixed profit contribution, and break-even volume versus profit contribution with one value of fixed cost. For the case of random variables, the program unit computes the mean profit and standard deviation versus volume. For profit analysis with probabilistic demand, the program unit computes the expected gain. Inputs to the program unit consist of fixed cost, unit revenue, standard deviations for fixed cost, unit revenue for the case of random variables, and a table of probability versus demand and maximum demand for the case of profit analysis with probabilistic demand. So let's see if we continue. So we have three choices here: analysis with deterministic variables, analysis with random variables, and analysis with probabilistic demand. We're going to run one first, and then we'll do the other two. So one, and we'll use data from a disk file. Of course, you'll enter your own data, obviously, and you can save it. So here we have, this is profit analysis. The product is a newsletter for microcomputers. We have the nominal value, lowest value, highest value increment for volume, unit revenue, unit cost, and fixed cost. Okay. So very interesting. That's the input data right there. I'm going to hit A for accept. I'm going to do C to compute. If you're putting in your own data, you would save the data at this point. Or you could go back to screen 1, but there's no point for that. So just C to compute only. and we'll just do screen length. You could, of course, send this to your printer. Screen length. So here's table 1. Profit with fixed costs equals $10,000, and the contribution is $4. That's profit per unit. So this shows the table volume versus profit. Obviously, you need to make more than 2,500 to make any profit. Profit with fixed cost equals $10,000 and quantity equals 3,000. So here's the contribution, and you can see you need more than 3 to have a profit here. Table 3, profit with contribution equals $4 and quantity is 3,000. And this shows you the fixed cost, the profit with the variation in the fixed cost. And then table 5 is break-even volume with fixed cost equals 10,000. So there you go. All right, so now we're going to exit out, come back into this program. You can look over the description again if you want. I'm going to hit C to continue. I already read that to you. This time we'll do 2, analysis with random variables. And let's load data. This will be file 3. Again, we're using this product as a newsletter for microcomputer. Microcomputers, low volume 1,000, high volume 5,000, increment is 500. And we're looking at the mean value and standard deviation for unit revenue, unit cost, and fixed cost. Okay? So you'd actually go through there. You know, you could hit E to edit, and you just step through it. And it'll tell you, just look at the prompt below. It tells you what you need to do. I hit A to accept, compute only, screen only, screen length. So here we have mean unit revenue $10, standard deviation $1, mean unit cost is 6, standard deviation 0.75, mean fixed cost of 10,000, standard deviation 2,000. So now we have volume, the mean profit, and the standard deviation. So there you go, all nicely lined up. Okay, so that takes care of this option 2 of program unit 4. So I'm going to exit to the module menu, come back in, go back to 4 again, and you know, again, you could look over the description if you wanted. I'm going to hit C to continue. Now we'll do 3, analysis with probabilistic demand. And again, let's look at a sample file. You can, of course, put in whatever data you want for your situation. Here we are assuming 9 demand levels. Maximum demand 5,000, unit product cost 6, unit selling price 10, fixed cost is 10,000. I'm going to hit A to accept. Now here there's this misalignment I was telling you about, but it doesn't really matter. If I hit E to edit, let's look at the index. What is the sales volume for demand level 1? What is the probability of demand for level 1? Etc. for all the other ones. So just hit enter to go through all these. Hit A to accept, C to compute, screen only, screen length. So here we have demand, sales volume versus probability input. And here's the result. Expected opportunity loss if product is developed, $320. Expected opportunity loss if product is not developed, $2,320. Therefore, the product is worth developing, and the expected monetary gain is $2,000. So, very helpful program. Okay, we're going to exit to the module menu. All right, so that wraps it up for today. This entire software package originally sold for $495. Because of the recession or depression due to COVID-19, we've reduced the price all the way down to $95. That just includes the software. We would send you a link from Dropbox. There's a nice manual that comes with it, but that's an extra $95 now. But as you can see, you really don't need the manual. Just read the description and just look at the prompts as you're going through each of the program units. It's really so simple to use. All the equations are contained within the program units. It's just very easy. This is the easiest way to apply operations, research, and management science. So I hope that you will continue with me as we go through this entire program. It still works great. Once you have the optimal solution, you have the optimal solution forever. So by no means is this software obsolete, not in the least. It still works perfectly. And I and the Transpower Corporation are still very proud of this program. Again, thanks for your attention, and we'll see you next week.